In this series on proof, I'm going to discuss proof by contradiction. So we use proof by contradiction when trying to prove a statement A implies B. We assume that A is true and that not B is true with the aim to reach a contradiction. We use proof by contradiction when faced with statements such as universal quantifiers, such as every x is. We also use contradiction with non-existence theorems of the form there is no such x as. We use these types of theorems as the negation of this are existence theorems, which gives us something quite easy to work with, or at least easier to work with. The main difficulties with proof by contradiction are knowing when to use proof by contradiction over other proof methods. It can also be quite difficult to work out not B. We now look at an example of this. Square root of 2 is irrational. So we use proof by contradiction as the contradiction of this statement is square root of 2 is rational, and this gives us something quite concrete to work with. So, the proof. We suppose for contradiction that there are some n and m belonging to all natural numbers such that the fraction n divided by m is equal to square root of 2, and we suppose that n and m have no common divisors, so the fraction is irreducible. We now take our fraction and get n is equal to m times square root of 2. This gives us n squared is equal to 2 times m squared. Therefore, n squared is divisible by 2, and therefore so is n. But since n is divisible by 2, n squared is divisible by 4. But earlier on we said that n squared is equal to 2 times m squared. So therefore, m squared is also divisible by 2. Therefore, we have a contradiction. Both n squared and m squared are divisible by 2, which contradicts the fact that n and m have no common divisors. Therefore, no such n and m exist, and therefore square root of 2 is irrational. We have a written version of this and other videos on different types of proof online. Thank you.